Hello Geometry! Today we're going to be talking about section 10.2, finding arc measures. To find the measure of an arc, that is the degree of the arc, we are going to be using the angles inside of a circle. The first type of angle we are going to talk about is a central angle. If you notice over here on the picture, I'm going to highlight this 100-degree angle. Where the rays of the angle meet is called the vertex, and the vertex is located in the center of the circle. So the definition of a central angle is the angles whose vertex is the center of the circle. This central angle also intercepts the circle. Now it intercepts the circle right here where these rays extend outward. So this distance here is the intercepted arc. That means the arc, I like to think of this like a Pac-Man, and if you imagined these angle rays closing, it is eating this arc inside of it. That is the intercepted arc. So the measure of central angles is going to be the same measure of its intercepted arc. For example, if you look over at the picture, at the angle that is 100 degrees, it is intercepting arc YZ. Since the angle intercepting this arc is 100 degrees, the arc YZ would also be 100 degrees. If you look at XZ, the arc XZ is being intercepted by an angle that is 120 degrees. So arc XZ is 120 degrees. Now we're going to talk about the measures of arcs. The measure of an arc is the degree measurement of the arc. So for the measures of arcs, we are not talking about length. Length and degree measure are different. So the measure of an arc is a degree. Now I want to start from the bottom and talk about a semicircle. Before we decide what a semicircle is, I want to talk about a whole circle. If you think about a circle and going all the way around a circle, that is 360 degrees. A semicircle is what would be half of a circle. So it is an arc that has endpoints that are the endpoints of the diameter, and exactly half of the circle. Now let's go back up to the minor and the major arc. I like to think of the minor and major arc to be like in a relationship. If you look over at the green circle, we have a minor arc and a major arc all inside here. The minor arc is less than half of the circle. It is the measure of its central angle. So if you look at the circle, I could say that arc B was a minor arc. It is a central angle and it is less than half of the circle. Now onto major arc, going along the lines of a relationship, the major arc is the rest of the circle. So the major arc is more than half of the circle, and it is the difference between 360 and the measure of the related minor arc. So if we refer back over to our circle here on the right, since AB, the blue highlighted portion, is my minor arc, my major arc would be what was left of the circle, which is the distance from B all the way over to A. But since it's a major arc, it has to be more than half of the circle, so I'm going to name that arc BCA. Since C and D are both in between, I could use either one. So my major arc of this circle is BCA, and my minor arc is going to be AB. A semicircle in this circle could be any point that is one end of a diameter, so for example B, to the other end of the diameter. So you could go one of two directions. I'm going to go across the top. So BAC would be an example of a semicircle. So let's practice. First I'm going to call this circle Circle P. And this is a symbol for a circle, and anytime a circle is named, it is named with its center point. So this would be circle C. This would be circle P. So let's find the measure of these arcs. So 1A says find the measure of arc RS. So I'm going to go to my circle, I'm going to put my pen on R, and I'm going to trace it all the way over to S. I'm going to notice that this arc is being intercepted by angle RPS. Angle RPS has a vertex that is in the center of the circle, so that means that this arc is the same measure as its angle. So that will be 110 degrees. Now let's look at the measure of arc RST. So RST, again, I'm going to take my pen, I'm going to go on R, I'm going to trace it all the way around to T. This is a semicircle. I go from one end of the diameter to the other, so that means that this arc is going to be half of the circle, which is 360 divided by 2, or 180 degrees. And last, I'm going to do the measure of arc RTS. So this one is actually going to go the opposite direction. I'm going to have to take my pen, go to R, and go all the way around, follow to T, and then to S. So there's two ways you can do this. You could add up all of the arcs around the circle, or I could notice here that the only section that is not included in this arc is the 110 that I found earlier, arc RS. So I could take 360 and subtract 110 from that to give me the arc RTS, and that is going to be the measure of 250 degrees. Now I want to find examples of a minor, major, and semicircle. So first, for my minor arc, I'm going to find a central angle. Arc RS is a part of a central angle, so that could be a minor arc. And again, I'm going to refer to my minor and major arcs to be in relationship. So since I used RS for my minor, I need the rest of my circle for my major arc. So that is going to be from the endpoint S all the way over to the endpoint R. So my major arc could be S, T, R, because I'm going all the way from S through T over to R. And last, I need a semicircle, and that's going to be half of the circle. So I could call this RST. We're also going to be working with congruent circles, and congruent circles are circles that have the same radius. And we will also be working with circles that have congruent arcs. There are two different points to this. Congruent arcs have the same measure, or it could be arcs of the same circle or of congruent circles. So let's practice. Example A says, is arc BC congruent to arc AD and Y? So first we have arc BC here in blue, and then we've got arc AD in red. So we have to decide, are these two arcs congruent? If you notice, the angles that intersect the arcs are both the same measure. Since the arcs are a part of central angles and the angles are the same measure, the arcs will be the same measure as well. So this would be yes, and you would say that the angles are congruent, therefore the arcs are congruent because they are central angles. Next, we have to find the measure of arc CD. So in green here is arc CD. To find the measure of arc CD, we can notice that ADB is a semicircle, which is 180 degrees. We can take what we have, which is the two angles of 80 degrees, add them together to get 160, and subtract that from 180 to find our missing piece, which is going to leave us with 20. So arc CD is 20 degrees. And the question says, is CD congruent to AD? The answer would be no. They are arcs of the same circle, but they are not congruent. They do not have the same central angle.